So for example number 3, this is challenging. We have the absolute value of 3x plus 2 is equal to 4x plus 5. And they say check for extraneous. Solutions. Now, extraneous is a fancy word that just means that these are extra solutions that won't mathematically work. So sometimes when we solve an equation, we can get x may equal -2 or x equals 5. And one of those equations may not work in the original expression. So we're going to solve this thing. There should be 2 solutions. There's a possibility that one of them might not work. Okay? So here, this is kind of challenging. How would I set that up? Well, what we have to think of is we could think of it in terms like this. We could say that 3x plus 2, the absolute value of that, is equal to some constant c. Now, the reason I say some constant c, let me move that out of the way there. Some constant c, because we know at some point in time, x represents a number, we can plug x in for the number, right? And then that would give us a number or constant c on the other side. You know, whatever number I plug in for x times 4 plus 5 should give us a number, right? So now normally how we would solve this is we would just say 3x plus 2 equals positive c, and then 3x plus 2 equals negative c. Oh, kind of ran out of room again. So now, how would we address that issue here? What's c? It's this stuff, isn't it? All right, okay, that's what I was leading up to. So now what we've got is we've got 2 scenarios. I've got 3x plus 2 is equal to 4x plus 5. And then over here I've got 3x plus 2. Let me move this out of the way. Is equal to negative 4x plus 5. And we got to put the 4x plus 5 in parentheses. Because whatever that number is, it has to be the negative of the whole thing. And the whole thing is 4x plus 5. Well, this is kind of simple. I'm going to subtract 3x from both sides. I get x, and then I get 2 plus 5 on this side. Subtract 5 from both sides, and I get negative 3 is equal to x. Cool. Let's do the other side. So now, if I push this negative sign through, this whole thing becomes negative 4x minus 5. So I'm going to add 4x to both sides. Let's draw a little line there so we don't get confused, and that's an x, not a y. So I get 7x plus 2 is equal to negative 5. Subtract 2 from both sides, and I get 7x is equal to negative 7, or x equals negative 1. Now you guys know how I got x equals negative 1, right? Or do I need to write that out?
No, we got it.
I just divided both sides by 7. Boom. These 7's cancel. Negative 7 divided by 7 is negative 1. Now, so check for extraneous solutions. So what that means is I've got to plug these in. Let me learn from my previous mistake. I'm going to say the absolute value of 3x, but I'm going to try negative 3 plus 2. And it should equal 4x plus 5. All right, so we're going to try something new here. This becomes negative 9 plus 2. Oh, you know what? I shouldn't put 4x plus 5. I should plug in my value for x, which was negative 3 plus 5, right? Duh. So now that should equal negative 12 plus 5. This becomes negative 7, and this becomes negative 7. Wait a minute. What happened? The absolute value of negative 7 is 7. Negative 7 can never equal positive 7. So what is our extraneous solution? Yeah, well, it's not negative 7.
Negative 3.
X equals negative 3 is an extraneous solution. All right, one more time. What was the other solution?
Negative 1.
Negative 1. Let's try that. So the absolute value of 3 times negative 1 plus 2, absolute value is equal to 4 times negative 1 plus 5?
Yeah.
So this becomes negative 3. I've got negative 3 plus 2. Absolute value is equal to negative 4 plus 5. This becomes negative 1. Right? Yeah. Negative 1 absolute value is equal to positive 1.
That's good.
That's true, right? Because the absolute value of negative 1 is equal to positive 1. So the only solution then would be x equals negative 1. Does that make sense?
Yeah.
Okay, cool. What do you need, sister?
I need help.